Hello, this is Satbir. In this video, we will learn how to use the chain rule with product and quotient rule. I have also some examples where we will practice the double chain rule. So let's begin this lecture. So in my first example, we will learn that how we can use the chain rule with the product rule. So I have two different examples. In very first example, we will use the product rule first and then chain. And this is another example where we will see that we will use the chain first and then product. So there are a product and chain rule, but the order here is a difference. So let's practice on the first problem. So our first problem, solution to the first problem is as follow. So we have a function f of x is equal to 3x square plus 1 to the cube and 4x plus 1 to the square. So we have the product of two functions. So their derivative will be using the product rule. So what is the product rule? If you have two functions f and g, and the derivative of the product is the derivative one function at a time, f g prime. So we will use that rule here, and we will see that when we use the product, we have to use the chain inside of that. So I'm going to use the Leibniz notation to write down the product rule. So the product rule say the derivative of the first term first, and we don't take the derivative of the second term. We will leave it as it is, and we add the derivative of the second term, but we will not take the derivative of the first term. So derivative of one term at a time multiplied by the another term, and then we add them together. So this is the product rule. So this is I use product rule. So now, since in order to compute the derivative of this term, this one, I have to use the chain, because this is a and that term, because both terms are a composite function. 3x square plus 1 is sitting inside of cube, so that is a composite function as well. And 4x plus 1 is sitting inside of x square. This is a composite function. So now we will use the chain rule inside the product rule. So according to the chain rule, so it's going to be a 3x square plus 1, 3 minus 1, you take 1 from the power, and then you multiply the derivative of inside term outside. It's going to be a 6x plus 0. I will not write 0. 4x plus 1, the square of that, and then plus 3x square plus 1 to the power 3. And then we will use here also the chain. It's going to be a 2 is going to be drop, and then going to be a 4x plus 1, 2 minus 1, and the derivative of inside outside, which is a 4. I can just simplify a little bit. This is going to be 12x, and this is a 3x square plus 1 to the power 2. And this is going to be a 4x plus 1 of square of that, and this problem is 3x square plus 1 to the power 3. That is a 4 times 2 times 4 is a 8. I will write it down here. And this is a 4x plus 1 to the power 1. So that's your complete solutions. So I'm going to box this answer. That's the fine. So you can see that here we use the product rule and chain rule, but we first use the product and then the chain rule. In the next example, we will use first the chain and then the product. So let's see how the solution of the second problem goes. So you can see that the second problem, the function g of x, you can also write a function g of x as a 1/2, as a square root can be written as a 1/2. So x cube square, 3x square x, and then this is a 3x to the power 4 plus 3x whole raised to power 1/2. So as you can see that now the product is sitting inside of the function square root of x. So we will use, because the product is inside a function. So since the product is inside function, so we will use the product loop second in the second place. First, we will use the chain rule. So therefore, g prime of x, what is a chain? You drop the power because it's a power function. Outside function is a power function. So therefore, 3x square plus x times 3x to the power 4 plus 3x, and you take 1 from the power, and then you multiply by the derivative of the inside function outside. So inside function, which is a 3x square plus x times 3x to the power 4 plus 3x. So now I will write down the product here then. So this is a 1/2. This is a 3x square plus x times 3x to the power 4 plus 3x whole raised to power -1/2, because 1/2 minus 1 is a -1/2. And since this is the chain rule, this is the product rule, sorry, and I will use here the product rule, means derivative of one function at a time. So dy by dx, the derivative of 3x square plus x, and the second function is as it is. So 3x to the power 4 plus 3x is as it is. And then I will leave the first function as it is and compute the derivative of the second function, which is a 3x to the power 4 plus 3x. And then parentheses here. So in the last line, I will complete the derivatives, and we will x square plus x 3x to the power 4 plus 3x to the power whole to the power -1/2, and then the derivative of the product, the derivative of the first term is a 6x plus 1 times second term as it is, 3x to the power 4 plus 3x, and plus 3x square plus x as it is, and the derivative of this term is basically 12x plus 3. This is a 12x plus 3. So that's your final answer for this problem. I hope this is a helpful, seeing the two different approach when you have to use the product first or when you have to use the chain rule. In our next slide, we will learn that how to use the quotient rule with the chain rule, or how to use the chain rule with the quotient rule. In the very first example, we will use quotient first and then chain. And in the second example, we will see that we will use the chain first and then quotient. So let's start the solution of the first problem. So we have function f of x 3e to the power x plus x whole to the power 3. And then we have 4x plus 1 to the square. How we use the chain rule? First, we do that. You can go back into the chain rule video and watch how the chain rule works. But basically, what we do is we will take the derivative of the first, which is going to calculate by using the chain rule. So this is a 3e to the power x plus x. You take 1 power, and then you take the derivative of inside outside, which is going to be a 3e to the power x plus 1. And then you divide by the derivative of the denominator function. This is a 2, 4x plus 1, and then derivative of this one. Inside is outside. And then we will chant that poem, low D high, high D low. So low to high and high to low, and that will complete the derivative of that function. So low function is a 4x plus 1, the square of that. High function is uh, this monster, 3e to the power x plus x to the power 2, 3e to the power x plus 1. So high D low, low D high. So low D high, high D low. What is a high function? 3e to the power x plus x to the power 3 multiply to the low, which is equal to 2 times 4 is a 8, and 4x plus 1, and whole entire, this whole big quotient is divided by low square, which is equal to 4x plus 1, the square of that, and the square of that. So that's complete the problem. You can see that we use first quotient, first we do the quotient, and then we use basically the chain inside of the quotient. Let's do the next problem. In that problems, we have to use the chain first and then quotient. So as you can see, the function g of x is the square root of 7x square plus x divided by 3x to the power 5 plus 3x 4 raised to power 1/2. So since the power function is outside and the quotient function is inside, so we will take the derivative of outside function first. So g prime of x, outside derivative of outside is a 1/2. The inside function will stay as it is, 1/2 minus 1. So this is a 7x square plus x divided by 3x to the power 5 plus 3x. And then the derivative of inside, we will write it out outside, which is a 7x square plus x. And this is a 3x to the power 5 plus 3x. So to compute the derivative of this term, we will use that cheat rule, which is a low D high, high D low chanting. But before I write down that derivative, I will simplify this one. It's going to be 1/2 7x square plus x divided by 3x to the power 5 plus 3x raised to power minus 1/2. I would compute the derivative of this function somewhere here, and then write down. This is 7x square plus x is in the denominator. Denominator term is a 3x to the power 5 plus 3x. I will take the derivative of top, which is gonna be 14x plus 1. I'm gonna take the derivative of the bottom, which is gonna be a 15x to the power 4 plus 3. And then I will do low D high. So low multiply to high, high multiply to low, low square. I will write down this here. It's gonna be a 3x to the power 5 plus 3x and multiply to 14x plus 1 and low D high and high D low. So I'm gonna raise that term from here. So low D high minus high function is a 7x square plus x multiply to the derivative of the low, which is a derivative of low is 15x to the power 4 plus 3, and whole entire thing is divided by low square, which is a 3x to the power 5 plus 3x, the square of that. So that's completed the problem. So where we use the chain first and then the quotient inside of that chain. In my next two examples, I will have the double chain or the triple chain. So where we will use more than one chain rule to find the solutions of this problem. So let's write down the solution of the first problem. The function is y is equal to square root of 1 plus e raised to power 1 plus square root of x. I'm gonna write that function is first like this. It's gonna be 1 plus e raised to power 1 plus x square to the power 1 half to the power 1 half. So I write the problem in term of 1 half. Therefore, the derivative of this function is going to be by using the chain rule. So you can see that this is the power function outside. So the x to the power 1 is a power of this function. So it's a outside, I will use the power rule. So it's gonna be a 1 half 1 plus e raised to power 1 plus x squared to the power 1 half. You take 1 from the power, which is gonna be negative 1 half. And then you take the derivative of inside, multiply it outside, which is going to be 1 plus e raised to power 1 plus x squared to the power 1. And then we have, if I simplify, this is going to be 1 half 1 plus e raised to power 1 plus x squared to the power 1 half 4 raised to power negative 1 half. And the derivative of 1 is 0. And the derivative of e to the power x is e to the power x, but there is a chain inside x square to the power 1 half. So I will take the chain and multiply for the derivative of outside. So here is this is inside function. The top is inside function of exponential. So it's going to be 1 plus x squared to the power positive 1 half. So again, simplify what we have calculated, and we will keep calculating the derivative of the function until we are exhausted all our chains. Then the derivative of 1 plus x squared to the power 1 half is again a chain. This is a power rule, and then its inside function is a 1 plus x squared. So power is a 1 half. You drop 1 plus x squared to the power 1 minus 1 half. This is the derivative of the chain outside function, and then the derivative of inside function is a 2x. So since this is the innermost function and we was able to calculate the derivative of that, so this complete the whole chain of that function. Okay, we have one more problem. Here we will use more than one chain. So let's see how to calculate the derivative of that one as well. G of x function is again x plus sine x to the power 1 half whole to the power 1 half. As you can see that we have the power rule outside, and then inside is that function. So we will take the derivative of outside first. So 1 half x plus sine x to the power 1 half 1 half minus 1, and the derivative of inside function is outside, which is a x plus sine x to the power 1 half. So that's our first chain. That's the first, basically the derivative of outside and then the derivative of inside. We will simplify the outside function, which is going to be a x plus sine x to the power 1 half 4 raised to power negative 1 half. And then we will take the derivative of this function. It's going to be a 1. Derivative of x is a 1. And the derivative of this function is again a chain rule, because the 1 half is outside function and x plus sine x is inside function. So we will use the chain here, 1 half x plus sine x to the power negative 1 half, because you take 1 from the power. And you multiply the derivative of these functions beside it, x plus sine x. So that's our last step. power 1/2, 4 raised to power negative 1/2, and then we write 1 plus 1/2 x plus sine x to the power negative 1/2, and the derivative, this is a 1, derivative of x is a 1, so 1 plus cosine of x, because derivative of sine is a cosine x. So that's your complete solution to the problem. Okay, I have one more question, which is a quiz for you to practice on it and see that if you have mastered the chain rule with